Good morning, friends. How are you all? I am Soso. Today I'll discuss the locomotive 110 volt DC control circuit. Already you know that our locomotive is a high powered circuit and its switches, its contactor, everything if you want to close, you cannot do it directly because this high power system will affect your body, means may cause your end of life, so it is very dangerous. So we are using control circuit with 110 volt DC, which is safe. So today I'll discuss this thing. In control circuit we are using two sets of contact. One is normally closed means when the magnet is de-energized, at that time which contact is in closed condition, that is normally closed, and in energized condition which contact will close, that is normally open. That means in de-energized condition, if it is in open condition, it is normally open, and energized condition, if it is de-energized condition, it is in open condition, it is normally open, and in de-energized condition which contact is closed, that is normally closed. The main thing is de-energized condition. In de-energized condition, which contact is in closed position, that is normally closed, and in de-energized condition which contact is normally open, that is normally open. But when the magnet will be energized, this normally open contact will be closed. So these two type of contacts we are using. I have shown in the drawing these two type of contacts, and this is shown in this way. Now how it operates, I'll show you. Let's see. Friends, in the picture both the contacts electromagnet is in de-energized condition, and in this de-energized condition one contact is closed, that is normally closed, and one contact is open, that is normally open. Now see, if I energize the normally closed contact magnet, it will open, and if I energize the normally open contact, then it will be closed. And this sequence we are using just like binary system, 0 and 1. So see how we are doing it. Okay. So you have seen, when the normally closed contact electromagnet energized, that means it has become red in color, then the normally closed contact has opened. So this is the system. Friends, the question is, then what is the function of normally closed and normally open? You see, these contacts when closed is making through the path of positive to the negative terminal. That means to complete a circuit, when the contact will be closed, it will continue a circuit, close a circuit, and when it will open a circuit. This is the use of these two types of contact, normally closed and normally open. Friends, for an example, the use of this contact, I'll show you a normally open contact when it will make, how it extends the DC positive and tipping a circuit breaker. So here in the picture, what we are doing, against a relay normally open contact, in one contact we are giving DC positive, and in the circuit breaker tip coil that has been shown in green color in the circuit breaker, the negative is permanently given. But when a fault will occur, the CT secondary is shown in green color also. The current will pass the relay, and relay setting due to this fault will attract the normally open contact. The coil will be energized of the relay coil and bridge the two contacts, normally open contacts, and DC positive will be extended to the tip coil of the circuit breaker, and one end is positive, another end is permanently given negative of the CB tip coil. So the coil will be energized and the circuit breaker will open. Circuit breaker will open and making the circuit dead. During any fault, the circuit breaker will live. This is the use of this contact. We are extending DC positive in TRD system, and in local control circuit also we are extending the DC positive to make a circuit, and when opening it, it will break a circuit. Here the overload the relay coil is making to break the contact of the circuit breaker. So we are using frequently this normally open and normally closed contact. Thank you, friends. Friends, here the DJ closing circuit, the VCP closing circuit of a locomotive, and the normally closed and open contact is shown in blue color. The battery is positive is red and negative is black. Fuse is also given in a rectangular form. Half portion is black and half portion is white. We are using frequently these fuses. Why? Because maybe any short circuit in the DC circuit also. So the fuse will be melt to protect the loco. Okay. So this is the system. Then we will do fault isolation and check where is the fault. But in power circuit, when a fault will occur, at that time also with the power circuit switch, step by step isolation we are doing and checking which one is faulty. Just like our power supply in domestic power supply system, one section will isolate, rest portion will be charged, and in this alternate we are checking what is the section is faulty. So this is the system. Thank you, friends. Friends, this is the locomotive control circuit with 110 volt DC. With this control circuit, we are controlling the power circuit. That means the 25 kV and high power other circuit like traction motor, all auxiliaries motors, and raising of pent in 25 kV. All these things will be controlled by this 110 volt DC. And here we are adopted this normally closed contact and normally open contact. The upper black line is the DC positive and lower black line is the DC negative. And the sequence we have programmed or designed, not a program, it is not computerized in the old locos. In this system, with the application of the close and open of the normally open contact and normally closed contact, we are making or breaking some circuit to according to our requirement. If to raise the pantograph, then we will send air pressure to the pantograph servo motor. But how it will go with this electromagnetic action, the pneumatic valve will be opened and air pressure will close the circuit breaker. and for traction motors, the auxiliary motors, the contactor will be closed by a electromagnet. It will open the air port and the air pressure will close this contact. So this is the system of the control circuit. It cannot handle the power circuit, the high voltage, high power circuit. So we are using this DC circuit, 110 volt DC in locomotive. In some state utilities, they are using 220 volt DC circuit. So, but we need DC circuit. But we need DC circuit for this control operation. And in traction distribution, in the AC relay, the contact is normally open contact and closed contact is DC. The delay may be AC, but with its contact, the DC positive will be given in one portion, and when the contact will be closed, it will be extended. So this is the basic principle of the controlling circuit of electric circuit. Thank you, friends. Today up to this.